Zong, would you like to take the mic to introduce the next speaker?
Yes, so I'd like to introduce Marco Lorenzi, Dr. Marco Lorenzi. He received his PhD at the University of Nice, then spent some time at UCL, and is currently a tenured research scientist for Fed-Biomed at INRIA Sophia Antipolis and at Université Côte d'Azur. And he will be telling us more about the Fed-Biomed open source federated learning platform.
Hello, thanks, Jung, and thanks for inviting me to participate to this workshop. It's very interesting, and it's a very interesting also approach you have for discussing in a community about technology. And so I'm going to share my screen. Let me know if you can see my slides.
Yes, looks great.
Very good. Okay. So I'm a researcher at INRIA, which is the French National Institute for Research in Informatics and Computer Science. And I'm going to present this initiative, which is called Fed-Biomed, which is an initiative that aims to develop software and the community around the idea of open approaches to federated learning for application in healthcare. So I assume you are quite familiar with the concept of federated learning, and so what it implies. It means it implies communication and some sort of trust between some participants, which can be hospital in our case, and some central entity, which could be an aggregator. So there are many frameworks which are available out there for doing federated learning. There are a lot of initiatives. But when it comes to practical, application of federated learning, so deploying in real life, there are many issues that make it that just taking a framework, whatever, out of the shelf and applying it it's not possible. It doesn't work because there are constraints, and we are required to provide guarantees and to be compliant with a lot of requirements in terms, for example, of security. In terms of compatibility with data, standardization, in terms of communication, so flow of data, in terms of governance, so who controls what, and who has the power to take decision in this collaborative infrastructure, compliance with regulation, and so discussion a lot about data protection and ethics. And also, systems has to be somehow something that can be sustainable, because we need a lot of cooperation and availability of resources, especially from hospital in this case, which is not straightforward at all. And that's where actually our initiative Fed-Biomed is positioned, which is developing a federated learning framework which will be compatible with the real world condition that we meet every time we need to collaborate with hospitals. So the first ambition is to develop something which is open, both in terms of code, but also in terms of governance. So it means in decision and ability to participate actually to the governance of the project and to the definition of the roadmap. And indeed, actually, the hospital we collaborate with, I will tell you a bit later, are part actually of the decision process and inspire our development, our choices, technical. We have a long-term planning. So in area, but in general, in France, there is federated learning is seen as a key technology. And so we are enjoying support, institutional, for the years to come for moving on with this initiative. And we have a commercial friendly license. So the requirement that we try to respect are, providing state-of-the-art technology and methods. So integrating contribution from the specialists, from research and industry about anything which revolves around federated learning, and providing guarantees when we need to interact with hospitals. So data, model governance, guarantees about compliance with the medical data format and specification, being user-friendly, so toward researcher, but also toward users, so clients, and providing interactivity, because we do research, we don't do deployment, so we don't need something which is a production, but we need also to try things because we want to do research. We are not bound to any hardware or any infrastructure which is proprietary. It's an open source consortium, it's an open consortium. And because we want to adapt to any deployment condition that in hospital can be very heterogeneous. So we cannot even assume that all the hospitals have a high capacity or very powerful workstation or clusters of GPUs. So we need to be very flexible. So the basic paradigm of Fed-Biomed is the typical paradigm of federated learning. We have something which we call a network, which is takes care of the communication between what we call a researcher, which is the person that is triggering the federated learning, and the nodes, which are the clients, which could be in this case the hospitals. So we have a messaging service that deals with the posting the research of the request from a researcher. So in this case, it's an MQTT server. And then the clients will look at this, this messaging server, and they will execute if the conditions and in the message is what requires to perform some action, and then they will post the response and so on. And within this, we have the typical iterative framework for example, triggering, training local and sharing model parameters. So the researcher, how would we trigger a federated learning experiment? So we are compatible to several machine learning frameworks, for example, PyTorch, scikit-learn. And in PyTorch, the idea is to be able to allow to deploy seamlessly a typical model as we would write in PyTorch just by copy and pasting section of the model in what we call a training plan, which is basically a wrapper of a typical training execution of, for example, neural network model, where we have to basically redefine or just implement how the model, what is the model, the components, how a forward step is implemented. And also we can implement also pre-processing that can be done on the data prior feeding actually to the model. So this is very compatible with what a researcher will do actually on his own workstation for training a model on some data. And then we have what we call strategies, which is all the parameters we need to specify a training, a federated training. So for example, which kind of privacy you want to enable, parameters about the training, and which kind of aggregator, how do we want to sample clients. So all the ingredients which are necessary to define a federated learning strategy. And all of this can be actually manipulated through Jupyter Notebook. So we have this interface which makes everything very interactive, so very research oriented, which is different by just deploying it through bash scripts and things like that. So it's very, like it's meant to be used for research, and we can run multiple experiments and so get multiple results about our federated learning process. From the hospital sides, we have this notion of data loading plan, which allows to gather together different data sources, attach some metadata, so in the form of tags, in such a way that the researcher can query the network with these tags and identify all the clients or the hospital that share the data which are compatible with the experiment. We allow control from the side of the clients because the hospital can override some sensitive parameters in case of need. For example, about resources usage, forcing the use of CPU or GPU, how many samples can be used. So what is the minimum number of samples that we would allow actually to use, for some privacy parameters in case. And at the end, the researcher will query the network and will be able to identify which centers is providing which data sets, and then run the experiment through the training plan as defined before. So for simplify the participation of the hospital, we have a graphical interface in which data set can be loaded, can be prepared, And then also we provide some verification tools. For example, to check the integrity of the files, to perform common standardization operation, to check that there is no inconsistencies in the data. For example, through metadata with respect to image data in the folders. And we assume that the data is compatible with the bits data format. So this is actually the format that we currently work with. We work a lot with security. So we encapsulate the entire framework within a VPN. So our security model is honest but curious. So we work first to protect the entire experiment from external attacker. And then within the network, where we guarantee that the flow is always outbound from the hospital. So we don't ask the hospital to open doors in their firewall for the incoming traffic. We provide the clients, so the nodes, with the ability to approve the execution of a certain model or not. So the researcher cannot execute any kind of code and model, but only model that have been certified and approved can be executed locally. And then we enable machine learning security through differential privacy. So we can perturb model parameters to protect the participation of a single data instance in the training data to produce the model. And we also provide secure aggregation. So we allow the model to be encrypted before the aggregation so that the researcher cannot access the model. So all of this is compatible with our assumption, security assumption that we have for this kind of federated experiment. And then just to talk a bit about the ongoing project we are supporting with our framework. So in France, we have this big project which within the Unicancer Consortium, which is a consortium of oncology hospital in France. So the collaborative problem that they aim to solve is training of neural network for classification from analysis of PET-CT imaging data of the lungs. And we currently have already deployed compatibly with all the recommendation requirements of the different hospital DPO ethical committees and IT staff. So we are currently deploying the framework, and we are already running experiment within this big project, this consortium that started a few months ago as an initiative. And this allows us to gather a lot of experience because in France, at least, it's extremely complex actually to set up a federated network and infrastructure. So we are actually quite proud already to be at this stage of deployment. And then we are part of other major project, collaborative project. So major EU project for a Federation of Cancer Institute. That this project UCAIM just started this month. This will be 4-year project. And so again, about federating data set for clinical and machine learning for clinical studies in oncology hospital in Europe. We work with the subset of the Enigma Consortium for Parkinson research, brain image analysis for biomarker development, with project across different hospitals for vascular brain analysis. I will tell you a bit more later. And so also we collaborate with the UK, with King's College for prostate cancer analysis. And all these projects are using Fed-Biomed to support their federated, or will benefit from the Fed-Biomed for the research. In particular, the project IBESEC, which I think is quite relevant for the kind of applications I assume you are interested in, which is so developing a federated infrastructure for allowing semi-weekly supervised annotation of the vascular tree or brain vessels. So it's a typically difficult segmentation problem because the structures are very small. And so with Fed-Biomed, will actually enable the training of the network, which is behind this weekly supervised method. And we will deal also with all the problem of bias quantification and correction in a federated manner. So there are 4 hospitals involved: Barcelona, London, Grenoble in France, and Siena in Italy. And this is a project that just started. And so all these tools will be integrated, will be part of the current roadmap of the project. And then we benefit also from industrial support and collaboration. Accenture, which is a big major IT player support us. They give us, they contribute to engineering resources that participate to our coding sprint. We support startups that will use Fed-Biomed as a key technology for developing their business, especially in a neuroradiology application. And we collaborate also with Oaking, which is another major actor in federated learning for developing, for example, open source project for federated benchmarking. So this is a project that we worked on last year. And so to sum it up, federated learning in health is very complex. It requires a very strong coordination between partners, standardization of tools and practices. Data is very complex. And there are issues definitely with governance, reliability, and security, so strong requirement. So what we are working on very actively is to develop, trying to meet all this need through this open project and open community. We have a particular focus on medical imaging application due also to, well, the original research interest of my team and area in general. So we, since as a community, we integrate state-of-art contribution from different researchers across different institutes, specialized in security, optimization, and engineering in general. And we are open, so the framework we aim at is something which is very concrete and that applies to general solutions. So we are not bound to any architecture. And so we have a very extensive set of documentation and tutorials that are available in our webpage, which is here, Fed-Biomed pages in the data file. And also, so if you want to know more about our ambition and goal, we have a white paper that we just released. So you're welcome actually to take a look. And this is everything. So thank you.
Thank you very much. That was an excellent talk. We're open for questions. I'm also going to suggest if people would like to get on camera and ask the question, they can also raise their hand and we can select you if you. But you're also welcome to put questions in the chat. So we do have a question from Mike Dwyer. Great talk, thanks. It sounds like you always have some fairly mature brain solutions that are actively working. Probably naive, but to what extent can we just cut and paste our training data and models into what you have already done?
Sorry for the typos, fat finger. but yeah, I mean, it seems like you already have a very mature system that's working across a lot of stuff. I mean, how much can we leverage that, by potentially collaborating and just putting our data in instead? So
the first answer would be, you can already try it yourself. You can download already the project. We provide a way to simulate the entire environment locally. So you can create on your machine, on your local host, your nodes, load your data, and deploy your model. So the answer would be, well, you can already try and see. I think so. We use actually for research in my team, my students that work on federated learning use Fed-Biomed for their research. So we have already a fair amount of possibility to integrate current benchmark. We work on typical benchmark actually for a medical image segmentation. I mentioned before prostate cancer and so on. So it's not that complicated already to use the platform for many data sets which are already available. So what is more complex is to meet the needs for real deployments, so installing things in hospitals. That's the other aspect. So as a framework for just testing model, running experiments, trying different strategies, different parameters, and so on, this is fairly mature. And I invite you to try. And then when it comes to the deployment, well, there are more complexity. So we are doing it already, but it requires engagement on both sides, because especially from the hospital side, because it's not straightforward. That's the real bottleneck.
Thank you.
So we have another question. Can you give an example on the GPU CPU limitations defined by the data providers? For example, what is the GPU CPU limit for the federated PET project?
Okay, limitation is typical on the use of the resources. For example, the researcher can say, I want to run this model on the GPUs, but on the node side, they might say, no, I don't want to leave to allow a GPU for this experiment because my machine, I don't know, I want to reserve for another experiment. And so they can disable the possibility of using a GPU for a specific experiment, so federated training. So in that sense, we are providing actually the possibility to control that. Not on the limit, for example, we don't control that yet.
We also have a question from Xiangjin Choi. Is there any open source tool available for 3D vessel segmentation?
That's a good question, because beyond any points to this project, so I recommend to take a look to this tool, which is called Vessel Capture, which is actually the tool which is at the basis of this project that I mentioned just before from my collaborator, Maria Zuluaga. I can point it to the paper, Vessel and I'm sure that they might have a pointer actually to the software there. And feel free to contact, actually, I'm not an expert of vessel segmentation, but feel free to contact actually the Maria, Dr. Zuluaga, and she's definitely an expert in that, and she can point to some of her work that we'll be using in this project, federated project, and maybe also other resources.
All right, let me ask one question. So we've heard about MedPerf and then your platform as well. Do your projects talk to each other? How do you? This could be a question for Alex too. I mean, is there? It seems like the projects are complementary. So I was wondering if you could comment on that.
I can go, Marco. You want to talk about it? But
go Alex. Yes.
we are both in France, so we enjoy the French culture. So we already been talking together. Yes, we have multiple meetings, and this year we're aiming to closely collaborate as well to talk potential because there's so many like you highlighted, there's so many intersections, and we want to help each other and try to address many of these challenges that are still open. And nobody has the holy answer yet.
Yeah, but there are specialists on both sides, and it's a very nice, very interesting discussion, very fruitful. Part of our development was also inspired somehow by the discussion we had by I think the two teams, development teams meet, and we had a couple of meetings this year. And so it's definitely useful and valuable actually on this interaction. And with Alex, we just met 1 week ago, actually, we said that we will try to seriously to do something to push this forward this year.
Excellent. There's actually another question in the chat, but in the interest of staying on time, I'm going to move on to our next speaker. But if you can answer in the chat, that would be fantastic.
Okay, sure.